Welcome back. Okay, so here we are in section 5.2. And you know what? I'm going to kind of tinker with the numbers a little. I'm going to make that a 67, make this a 110. Oh, I don't know, make that 118. Okay, there we go. And and then that way, when you guys do this in the homework, it won't be like, well, all I had to do is copy it from that, from Mr. Borman's video, because I mean, let's face it, that's boring, that's lame. Um, okay, so it says use regression to find a logarithmic equation to model the data. Oh, wait. So the relationship between the diameter and height of a particular tree is shown in the table and graph. I think we had the same data or similar data back in chapter 1. I don't know. Maybe we did, maybe we didn't. But we did. I know we did tree stuff in chapter 1. Okay, so we're supposed to use regression. So that means, oh, we're going to the calculator. We're doing the L1 and L2 and all that, and we're doing logarithmic, not linear, quadratic, power, exponential. Okay, so I'm gonna go stat enter. Okay. So I've got all the data typed in there. I didn't, I just paused the recording while I did it. I double checked all my data that it's exactly the way I want it. So then I'm going to go to stat over, and then this time I'm going to go to logarithmic. Now there's a bunch of things here that start with L. Well, we know it's not 4 because we use that for linear regression, straight line patterns, if the data is in a straight line pattern. And number 8 is the same thing, except instead of having the slope be A and the y-intercept be B, they just swap it. That's all. I don't know why they do that. I don't know why there's an extra option. Number 9, that is logarithmic regression. Okay. The LN stands for natural logarithm, which is, you see that the LN button just to the left of your number 4 button on the calculator. Okay, so I'll pick that, make sure it says L1 and L2, and then we're going to go down, and we got it. Okay, not a big deal. So we're going to say, all right, the equation is y equals a, which, oh, and of course, I don't remember how many decimal places we're supposed to round it off to. That's just my style of not knowing. 2 decimal places. Got it. So y equals 40.07 plus b. So we're going to add b to it, which is 49.26. And then multiplied by ln of x. Okay, what the heck does that mean? I'm glad you asked. Okay, so ln is a function. It's the natural log function. And the x is what's being plugged into that function. All right. So you can put the parentheses there. You don't have to. It's up to you. It'll be fine either way. But yeah, whatever is right here, that's what's being plugged into this function. All right. Okay. So we got that super cool thing. And okay, I got to turn that off. Go back to here. Okay. So that's part A. Part B, use your equation to estimate the height of a tree with a diameter of 6 feet to 1 decimal place. There, I read it first time. Okay, 1 decimal. So they're giving us diameter. Diameter is an x value. It's on the left. They want us to find height, which is on the right. That's a y value. So we're just going to plug 6 in for x, like we always do. All right. So, and of course, because I changed some of these numbers, you're going to get a different equation when you actually do the homework. It won't be very different. It'll be very similar because I didn't change these. I only changed 3 numbers and I barely changed them at all. Okay. So what is the height of the tree? If you have, excuse me, a diameter, well, the expected height, I mean, it won't be exact. The expected height of the tree, if you have a diameter of 6 feet. Okay, so we're going to plug 6 into the ln function. All right, I dig it. So, all right, so I'll go 40.07 plus 49.26 ln. So I hit the ln button. And this button here, that's log base 10. This one's log base E. I have not explained what that means. I don't think I ever get around to it in the class. Okay. And boom, 128.3 feet high. Okay. And I'm going to include my units. Feet. All right. So does that seem reasonable? Based on all the other data. Well, the data only goes up to 5 feet high, or I'm sorry, 5-foot diameter with 118-foot height. And so if you go up 1 more foot in diameter, yeah, we expect the height to increase. I mean, not like, hey, now it's 500 feet tall, but a bit. And so, yeah, it goes up another 10.3 feet. Okay, cool. So that's how that's done. And of course, we could look at the graph as well. Let me get rid of some of that right there. There, now I can read a little better. We could look at the graph and say, all right, well, at 6-foot diameter, that's right here on the right side edge of the graph. What does it look like, our y value is going to be? Well, if I have to draw a little further, so maybe about like that. And then I would say, oh, okay, well, that's going to hit right about there. And yeah, it looks like it's hitting just below the 130 mark, which is consistent with our 128.3. Okay, so if I just kind of double check it off the graph, I feel pretty comfortable with my answer. Okay, part C. What do we got here? I need to erase a little. Okay, use your equation to estimate the height of a tree with a diameter of 8 feet, accurate to 1 decimal place. Okay, so then you just plug in 8. And of course, because we're using TID4s, which are super cool, I'm just going to arrow up, hit enter to grab that, and I'm just going to go here and say 8 feet, boom, 142.5-foot height. Okay, and that's the cool way of doing it. But you don't have to be cool like me. All right. But it's really not recommended. Anyway, that's all I got for this section. Go forth, conquer, and be awesome.